The next set of VDC services will include the VDC support services like risk support, claims analysis and mitigation, worker training and safety, and also construction quality assurance. Let's talk about risk support. Risk workshops are used to gather responsible parties in one room to analyze the potential issues that the project can actually give rise to in terms of risk. And during the risk workshop, there could be different types of building information models that the participants may choose to use to analyze the risk associated at different stages of the design stage or the construction stage. For example, 4D schedules and their potential outcomes configured through the information models can be showcased live on screen during the meetings. This visual feedback will clarify the different risk factors, and it will also improve the decision-making process by the different stakeholders at different stages of the project cycle. Next, we go on to claims analysis and mitigation. In today's complex construction industry, characterized by rigid time constraint, multiple prime contracts, and phased construction programs, claims have become a constant part of the construction process. In the case of litigation, BIM models can provide simulations of the situation to clearly communicate the cause of claims to all parties. This is especially true if the project was tracked using a tracking model, as it is a virtual record of the whole construction projects, and VDC can allow for that to be done in an easier and more effective manner. Worker training and safety awareness are essential to the success of a project. Through VDC tools, project modeling and construction simulation can be used for simulating, planning, and demonstrating proper working methods for all workers and different stakeholders. Utilizing a logistic model helps in visualizing and addressing safety concerns, as well as supporting efficient on-site construction operations with comprehensive safety practices. Quality is of paramount importance to all stakeholders in the project, and VDC tools can offer construction quality assurance. On-site digital surveying and measurement technologies can assist with establishing actual grading geometry, site-built construction, and installation. On-site data can be compared against required locations of construction as specified in a project BIM model. Comparisons of specific versus actual construction can be used to verify quality of construction and support the accuracy of subsequent systems. All this showcase how VDC services can be used to enhance or to achieve construction quality assurance. The third set of VDC services consists of VDC production services. And in this slide, you can see 16 examples of the VDC production services. We will be going through in detail on all these 16 examples. The first one is visualization. VDC generates performance-driven visualizations, and it can come in a form of images or animations or live virtual walkthroughs or even experience simulation. The visualization will help all the project parties quickly understand the project, especially participants who are not skilled in reading 2D documentations and specifications. Identifications of issues becomes crystal clear, and all parties can take part in the discussion to resolve them, rather than to spend time and energy establishing the topic of discussion. The types of visualization results could be highly realistic experience animation that convey the final experience of the facility, or color-coded coordination studies meant to communicate concepts, discrepancy, performance criteria, issues, and interference. VDC Experience Simulation. A walkthrough of the final constructed design should be shown with the highest possible realism to convey as closely as possible the real experience of the place. That will allow the different stakeholders to understand what they are building towards. VDC can also provide visualization of the different systems that make up the facility. Visualizations used for system coordination can be color-coded by subsystems, so some elements can be made transparent or turned off to bring relevant information to the forefront. The VDC teams tailors each visualization experience to include exactly the necessary data and highlight what is of interest. For some types of visualizations, it is best to provide both 2D and 3D representations, as 2D help with the location information such as room, grid, zone, and levels. VDC Services also offers 3D printing that allow the stakeholders to study the complex shapes or connections. 3D print is easier to understand than a model, and that will allow for useful understanding of construction sequencing such as mockups. VDC services can also be offered to allow for contract scope visualization. An information model can be used to clearly and precisely visualize the scope of different contractors' responsibilities, tie the scopes and the costs to associated quantities extracted from a model, and highlight critical interfaces between the different contracts. This capability removes ambiguity and potential inconsistencies regarding different parties' responsibilities and helps contractors to provide bids that correspond correctly to the proposed work. At a very basic level, 3D modeling allows the contractor to quickly understand the scope of the project, particularly for projects that involve many contractors and subcontractors with potentially complex interfaces and a possible overlaps between the different contract scopes. VDC services can also be used for proposal presentations. To help to convey these designs and construction concepts, VDC products can be included as an integrated part of any proposals to the client. This helps not only to communicate how the job will be run, but also demonstrate how VDC will be used throughout the project as an integrated part of everyday workflow. Developers often request for proposal or RFPs in order to select winning contracts for design, construction, and the managers and the contractors. Proposals include documents that illustrate their understanding of the project as well as the proposed method of execution. This can include design, staging, phasing, access requirement, scheduling, team configuration, and a range of other qualifications. VDC can allow for field capturing of data. For example, the use of laser scanners. Laser scanning creates accurate 3D point cloud that includes every inch of visible surface area. This point cloud data can be linked to BIM to model the space or validate existing information models. Some specialized plugins for the information modeling software are currently under development to directly model the architectural, structural, and system components simply from point clouds. Another example is the use of X-ray. X-ray methods can be used to detect objects hidden underground or inside a wall. However, they are costly and can only detect certain materials and reach a certain depth. While we are using technology, we also need to be mindful of the limitations of the technology that we are using. Some of these methods for data capturing do have limitations, as they only show the element's geometric representation and not its composition. For example, a 3D scan cannot differentiate between a pipe or some other cylindrical object such as a round column, or between different types of pipes. VDC also allows the stakeholders to carry out a constructability studies for the actual project. In the olden days, where we don't have access to technologies, we tend to rely only on 2D documents to allow us to carry out the construction, and the 2D documents share the data, okay, or in the sense of the representations of the intended construction. That is actually not very effective. And then we started to move into building information modeling, or BIM model. So the BIM model includes every single location, and all the traits can be linked into one file. The relationships of the model can also be studied in greater detail. And this way of doing the construction is actually more superior over the 2D documentation or 2D drawings. But that is still not good enough, and we are able to now tap on VDC services to allow us to carry out constructability studies. Now, what is constructability studies? In a sense, VDC can allow us to virtually construct the building even before we start the actual construction. So when we are carrying out the virtual construction of the building, we still need to utilize all the different trades, okay, the different stakeholders to come in to do the construction. So in a process, we are able to start to discover what are the range of problems and issues that we have while we are constructing the building virtually. Yeah. So the lingo for VDC construction is always build twice. First virtual, then the second one, the actual physical construction. And the advantage of that is that during the virtual construction, you can surface and start to discover what are the problems and solve the problems in advance. And when you are starting to build in the physical environment, you have already discovered the problems, okay, the solutions to your problems. Yeah. In addition, the projects can be visualized over time, and the project development can be linked to a schedule, and the quantities can be used for cost estimating. So real issues can then be rectified even before the construction actually starts. So that is what we meant when we say constructability studies. In this particular project, a constructability study was carried out to integrate the different design services together with the structural element, and a constructability review report was shared with all the different stakeholders in a meeting. So from the constructability review report, everybody can see what is the source of the problems, and the different stakeholders can agree on the spot, okay, to rectify the problem, and the models get changed immediately, okay, to resolve the problem on the spot. So we don't need to wait for the problems to resolve over the next few days. So with this type of workflow, things can be done in a faster manner.